So next we have a problems on RLC circuits. A series circuit with a resistor of 100 ohm, capacitor of 25 microfarad and inductance of 0.15 Henry is connected across 220 volts, 50 Hz supply. Calculate impedance, current, power and power factor of the circuit. So first here the given values are, one is resistor and that is 100 ohm, capacitor that is 25 microfarad, inductance is having inductor is having inductance is 0.15 Henry and voltage is given as 220 volts and 50 Hz of the frequency. Then here we need to find out the impedance in the sense, so Z we have to find out, and then the current, power factor. So here from the given problem we have to write a circuit first. So what the given problem says, then the circuit is in the series. So that is what resistor, capacitor and inductors must be connected in a series manner. For this we have to connect a voltage that is having a voltage of 220 volts and having a frequency 50 Hz frequency. So here in order to find out the impedance we have a formula, that is for RLC circuit we are having a formula for this, that is Z is equal to R plus J XL minus J XC. So this is what the formula we are having. So here in order to find out the Z we required is XL and XC. So in order to find out the XL and XC we have a formula, XC is 1 divided by 2 pi F C and XL is equal to 2 pi F L it is. So substitute the values of frequency and the capacitor over here, and then in order to find out the XL, so just substitute the value of frequency and the inductance. So you'll get the values of 47.124. So that is the XL, and XC is 127.324 ohms it is. Then here we can easily find out the Z value, that is impedance. So Z is equal to 100 plus J 47.124 and minus J, so you just substitute the value of XC. So later on if you calculate this you'll get values like this, that is J 80.2 ohm. So this is what this value is in rectangular format. So which format it is? Rectangular format. So this you have to represent and you have to find out the value of in polar. So you all know how to convert rectangular to polar format. So if you calculate by using a calculator, the polar format of the Z value is 128.18 minus 38.73 degree. Ohm will be the what? Polar form of the impedance it is. So polar form of the impedance. And then after finding the Z value, here we have is what we need to find out the current value. So in order to find the current value we have a formula that I is equal to V divided by Z. So we all know that is 220 volts. So 220 you just write it out, and then we have is 128.187 degree. So this is what we need to keep the Z in a polar form for dividing. So then if you divide this by this you'll get as 1.716, and later on no need to touch this. Here we don't have any polar any angle for this voltage value. So here negative will be positive 38.7 degree amps it is. So since it is a current we have got a value of current here, and then later on we need to find out the value of power. So that is what power we need to find out. So in order to find out the power we have is I square R, that is equal to, we all know what is I square. So just to take the magnitude of this, and then magnitude of this will be 1.716 whole square into R is what? 100. So then you'll get a value of P, that is 294.46 watts it is. And then so in order to find out the power factor, so power factor of the circuit we have is cos phi is the power factor equation. Cos phi is equal to cos phi. What is the value of phi here? So for the impedance, this is what the magnitude of the impedance, that is Z magnitude, and here is what the phase, that is 38.73. You can write negative or positive here. So cos minus theta will be positive cos theta only. So therefore, if you consider this negative, so it's your wish. If you want to write negative sign, you write, otherwise you leave. So then you'll get 0.78. So the power factor what we are getting, that is getting a positive value. That's why we can say it is a leading one. So if it is leading means what we can say, XL is greater than XC is greater than XL, we can say. So finally, once you find out the power factor of the circuit, so you can write the power easily. So since the condition is what, XC is greater than XL, in this condition we are having a power equation, that is VI cos phi, that will be equal to 220 into 1.76716 into cos phi is 0.78. So that is equal to 294.466 watts. So this will be the what value of power when the condition XC is greater than XL. So therefore this is what the question, the impedance, current and power factor of the circuit needs to be find out. So this is what the overall problem. Yes, next problem, second problem in this RLC combination is a coil of power factor 0.6 is in series with a 100 microfarad capacitor. When connected to 50 hertz supply, that is having a power dissipation across the coil, is power dissipation across the capacitor. Find the resistance and inductance of the coil for the circuit shown in the figure. So this is what the given circuit we have. So here in this circuit, if you observe, this is what the resistance and the inductance both forms a coil, and series connection with this is capacitor. And here the power factor is 0.6, capacitance is 100 microfarad, frequency is 50 hertz, and RL needs to be find out. So here R and inductance will form a coil, and this is having a voltage Vx, and this capacitance voltage drop is what, Vc. We can say this Vx is equal to Vc because these two are in series combination. That's why we can write this Vx is equal to Vc. So in the given problem also they are telling that power dissipation across this coil is same as the power dissipation across the capacitor. So here, in order to find out the R and L, let us start with the impedance of this coil. So let me call the impedance of this coil is what, Zx it is. So impedance of the coil it is, so it consists of resistor and the inductance. That's why I am writing R plus jXL. You all know this equation. So this is what the impedance, and here in the given, the coil power factor is given. So the coil power factor is how much it is, 0.6. The power factor we can say it as cos phi. So we already discussed for the resistor and the coil power factor, the cos phi can be write it as R divided by Zx. So Zx, you all know, right, that right angle triangle, so where phi will be there, and this is the hypotenuse, this is what the adjacent, and this will be the opposite one. So here we have written VR, and here we have written is Zx, and then here it will be VL. So here cos phi in the sense adjacent divided by hypotenuse. Adjacent we have as resistance R, and hypotenuse we have as Zx. So that's why we can write R divided by Zx it is. So then Here what is given here? So r is also unknown and zx is also known, but we are having an equation for zx and power factor, let me write here 0.6, and 0.6 is equal to r divided by zx is r plus j xl it is, and then this is what 0.6 is equal to r divided by r plus j xl. So here instead of writing this, so let us have this in a magnitude format, that is r square plus j xl it is. So here if you consider this will not be there, that is j will not be there. So magnitude of this zx is equal to r plus j xl. Magnitude of this will be square root of r square plus xl square it is. Then we have is square root of r square plus xl square, that is equal to so here if I take here 0.6 it is, and then square root of r square plus xl square equals 0.6, 1 by 0.6 will be 1.667 r. So then if you apply a squaring on both the sides, r square plus xl square is equal to 2.77 r square it is. Then here if you simplify this, you'll get 1.77 r square is equal to xl square. Then r can be write it as 75 xl. This is what the equation of r it is. So here we can write our Vx is equal to Vc. Since these two are series combination, so we can write Vx is equal to Vc. Why am I writing this is, we all know what is Vx and also what is Vc. So we can write Vx and Vc in the form of Z. That I can write it as I into the magnitude of zx and I into the magnitude of xc it is. So here I gets cancelled. We have is zx is equal to xc it is. Reactive capacitance, reactance it is, and then we know this is what the equation we have got. We all know what is xc. X is equal to 1 divided by 2 pi fc. So xc can be write it as, if you substitute all the equation, pi 50 into 100 micro, so you'll get xc as 31.831 ohms it is. So this is same as x. So that's xc is equal to zx. So zx can be, magnitude of zx can be write it as 31.831. Therefore zx in the sense, so here we have a value of zx. If you take the magnitude of this, you'll get square root of r square plus xl square, that is equal to 31.831. Sorry, this is 31.831. Then we have as r square plus xl square, that is equal to 1013.211. Then we'll get the equations. R is equal to 0.75 xl and r square plus xl square is equal to 1013.21 it is. So this is what the first equation we have, and this is the second equation. If you solve both the equation, here R is equal to 0.75 XL. So let me substitute in the second equation. 0.75 XL square plus XL square is equal to 1021, and then we'll be having is we'll get the XL value from this equation will be 25.46 ohm it is. Okay, from this XL we have a formula that XL 2 pi f L it is. Therefore, from this L you can find out L can be XL divided by 2 pi f. XL is how much? It is 25.46 divided by 2 pi into 50 hertz. L will be 0.081 Henry. And then L, we already know from this R can be, R is equal to, we all know R is equal to 0.75 into 25.464. R can we write it as 19.098 ohms it is. This is what the R value. So here we all know R is equal to 0.7 XL. So if you substitute XL value here, you'll get the R value. So this is what the problem we have.